If you were at the Hardin County workshop 2 weeks ago, this is the same presentation, so fair warning. If you want to leave, you won't offend me. Or maybe sometimes if you hear it twice, maybe it makes more sense. I don't know. But I'm going to talk about improving soybean production in Ohio. More specifically, some of our yield gap research. This was funded by the North Central Soybean Research Program. And if you were here last year, you probably heard Sean Conley talk about this project some. Anyone remember that-ish? Yeah, so this is wrapped up now. We have 3 full years of data, and this was a phenomenal project. A lot of you guys participated. This is the one where we had the paper survey or the Survey Monkey link I sent to you and you filled it out. So I'm going to summarize some of those results. So when you plant a soybean variety, there's a yield potential, and the yield potential is determined by the environment. So the carbon dioxide, temperature, water, things like that. And different areas of the U.S. have different yield potentials. Ours may not be as high as maybe Iowa, and North Dakota's is lower than ours. So it depends on your location. But growers, regardless of their location, don't achieve their yield potential. There's some limiting factor: fertility, insects, weeds, diseases, something that's reducing yield. And the difference between the yield potential and what you actually achieve on your farm is the yield gap. So the goal of this study was to identify, first of all, what is the yield gap, and then second of all, what is causing the yield gap. So this is the area, the study area. It's a North Central project, so it included all the states in the North Central region except for Missouri and South Dakota. We collected surveys, and I had them at CTC probably the last 2 or 3 years. The red dots here on the upper right corner indicate where we collected data. So Ohio was really well represented, which is great. Part of the survey was to get the GPS locations of these fields. One of the reasons we did that was to see what environments those fields were in. And so there's a system called Technology Extrapolation Domain, or TED. And those are the different colors on the map here. I think there's 9 different colors. These are looking at areas, grouping areas together that have a similar environment. And that's based on 4 factors: growing degree days, water availability, things like that. So for example, here in Ohio, the northern part of Ohio, a lot of it is purple. That purple area is a similar growing environment to western Michigan. And then the rest of Ohio is predominantly that blue color that goes into Indiana. This map was created with just the first year of data. You can see Northwest Ohio doesn't have much color there. If you look, we have a lot of data. We got a lot of data from growers in Northwest Ohio. So what does this tell us? Northwest Ohio is weird. So we can group a lot of this part of Ohio into Michigan and some of Wisconsin and some of into Iowa. Blue area we can lump into other states. That little area of Northwest Ohio isn't really similar to anywhere else in the U.S. And I think that's a really good take-home message. So we are able to get more, as we collected more survey data, we were able to populate that a little bit more. But we had data, it's just not similar to any other places in the U.S. So keep that in mind. So the first step was to quantify the yield gap. So we looked at the yield potential. The yield potential is based on models. So what, in a given environment, what is the yield potential of soybean? So that's where that came from. Then we subtracted it from producer yields. That's what you guys self-reported on your surveys. We subtracted that, and that's the yield gap. What was really interesting as an agronomist, as really a group of agronomists, we were worried that the self-reported data wouldn't work. Because we're used, Harold's used to doing trials. You plant, you do something, you manipulate something, you measure something. The paper survey, I was really skeptical if it would work. But the farmers we worked with self-reported extremely accurately. We were able to compare our data to USDA data, and there was a really good relationship. So I think that's really cool to see. So what is the yield gap? These are the 9 regions that correspond to the 9 colors here. So region 1 is the purple color across the northern part of the state. And then region 2 is that blue color. The blue color is mostly central and southern Ohio, but it does kind of curve around to part of Hardin County and then up into Hancock County. So there is some of that blue area here in this, where we're at now. So region 1, again, was that purple area, northern Ohio. What you're looking at is the 2 years, 2014, 2015. The yellow, where the yellow bars go, that's the self-reported yield data. And then where the white bar starts is the yield gap, what is missing. So in northern Ohio, region 1 here, across those 2 years, the yield gap was 26%. So we were estimating farmers across that northern strip of Ohio were missing about 26% of their yield potential due to some management, insect, weeds, some factor. What I think is really cool here in region 2, which is Hancock County, part of Hardin County, and then central southern Ohio, the yield gap there is 15%. Is anyone surprised by that? That's pretty small, exactly. That's pretty darn good. So looking across the other states, R3 is North Dakota, so their yield potential is lower than ours. Their yield gap is 22%. Going across to the I states, they're in 22, 26, 28% yield gap. So they may have a higher yield potential out there, but the farmers here in region 2 are doing a pretty darn good job. The blue graph, or the blue bars, those are irrigated conditions, so that's mostly Kansas and Nebraska. Their yield gap is smaller, but not exactly the same system as what we have here. That's all irrigated. So I think that's pretty cool to look at. And I always brag to my colleagues that I think Ohio farmers are better than their farmers, and none of my colleagues are here. So there we go. But 15% yield gap, I think that's pretty neat. So once we identified that yield gap, or estimated that yield gap, the next step was why? What is causing that 26% or that 15% loss? And so what we did, we compared management practices in fields that were the lowest third yielding and the highest third in terms of yield, and tried to identify factors that explain that gap. And this wasn't all-inclusive. This was a paper survey, so we asked about seeding rate, planting date, weed control, things like that. We couldn't measure SCN. We asked people to self-report it, but I'm not extremely confident how accurate that is. We couldn't get a good idea about soil fertility. We didn't pull soil samples, so we couldn't include everything, but we did have a good list of management practices. So the 4 things that rose to the top, and I think you heard this from Carrie. If you were here for Carrie's talk, planting date, and you've probably heard that a lot this winter. Planting date was really important. You heard this from Seth. I think he talked about tillage and drainage both. And then in-season foliar, fungicide, and or insecticide were important. The reason those are grouped is because we can't separate them out, because the majority of people tank mixed them. And so we know they did both, but we don't know what caused any yield benefit. And of these four practices, planting date was overarching the most important. This is our planting date research, or planting date results. So here, the 9 boxes represent those 9 different colors on the map. What you're looking at here, I don't know if you guys can probably see that at all, is on the y-axis is soybean yield, and on the bottom here is days planted after April 1st. The data doesn't start until about the 3rd or 4th week of April. Those are the earliest planting dates we had reported. So region 1, this is that northern strip of Ohio. The yield penalty for planting after the end of April was a 1/2 bushel per acre per day reduction in yield. So that's a big number. Some of our small plot data on planting date is pretty similar. I got 0.6 bushel per acre per day. So planting date is really important. Going to region 2, that's box B. This is that part of Hancock County and then down to southern Ohio. The yield penalty there wasn't as great. It was about 0.2 bushel per acre per day. Not as great. C, that's North Dakota. North Dakota has a flat line, and they planted the end of April all the way through June. Why does planting date in North Dakota not matter? All I hear is whispering. I have children, so I cannot hear anything. So the whispering just, yeah, you have to be screaming at a really high decibel for me to hear.
They're dry all the time, right?
They're dry all the time, yeah, they're dry. So what they looked at, the researchers looked at here with the study, they looked at the yield penalty versus water balance during pod setting. And so down here, region 3, there's no yield penalty for planting late. But they also have an extremely negative water balance during pod fill, so they run out of water. Region 1, where there was that half bushel per acre per day reduction in yield, they have a negative water balance, but not as negative. The irrigated soybeans there in blue, no negative water balance, and they all have a pretty high yield penalty for planting later. So you don't know what's going to happen at pod fill. We don't know if you're going to run out of water or not. So planting early is important, but sometimes we don't see a yield response to planting date, and it's probably because of this. So drainage was also important. These yellow circles represent the regions. Region 2, there was significant benefit in terms of yield when fields were artificially drained. I don't think that's a surprise to anyone that there was that yield benefit to tile drainage. Tillage was also significant for region 2, and fields that were tilled, yeah.
Sorry, that seems to contradict the guy from Minnesota. So he was saying there was no real advantage to tiling, wasn't he?
I think he had two. And he had 2 years of data, so I think the first year, 2017, there was a slight advantage to tile drainage. But the second year, I think you're right, there was no advantage, or maybe there was some, yeah, it was, yeah.
It's not surprising here in Ohio that we have an advantage. So are we in this region 2? Is that what you're saying?
So region 2 would cover Hancock County, and then the northern part of Hardin County. Where you're at, you were borderline. We looked at your fields. You were borderline region 2. Yeah, so it's going to depend on the year. Maybe I should have paid more attention to Seth's talk, but don't tell him that. But I think he had different results per year, and I don't know where Minnesota is on here either. What color they are. So they're kind of that green and purple. So they would be region 1, and then whatever that green color is, I'm not sure. So they're not in the same region. They would be region 1, which there was a slight yield advantage to artificially drained fields, but not statistically significant. And the other thing I always tell people when we look at this data, this is averaged across all of the survey data. This isn't going to say you have an advantage for sure or you won't have an advantage for sure. These are just large trends across a large area. Yeah. For tillage region 2, again, this is part of the Hancock County, Hardin County, and then going south. There was a slight advantage to tilling fields. It was probably 3 to 4 bushels per acre in favor of tillage versus no-till. There are other reasons you may choose not to till, but that was the overarching trend for just that region. Region 1 in Ohio, there was no difference. Foliar, fungicide, and insecticide was significant in a lot of areas with a yield advantage with having those foliar applications. In Ohio, there was a slight yield increase, but it wasn't statistically significant, and I think this is probably accurate. With our small plot data, we see a yield benefit about 1/3 of the time to a foliar fungicide. So if you're in southern Ohio and you have frog eye leaf spot or some disease, you will get a yield benefit from a foliar fungicide. But just spraying a foliar fungicide or insecticide probably won't give you a yield response unless you have some underlying pest there or disease. Any questions about that before I move on? Yeah.
Your tillage, is that like a vertical tillage?
So that's a great question. So for the tillage, we asked the farmers to report what kind of tillage they did, and so they would put disc, chisel, whatever. Vertical was an option. When we went to analyze the data, we had to lump it all together, either no-till or till, because if we didn't make large, I guess, baskets of till versus no-till, we wouldn't have enough data to analyze. So if we had enough survey data, we could separate out vertical versus chisel versus disc versus field cultivator, all of that, but we didn't have enough data to do that. So that's all tillage practices lumped together. Any other questions about that? So that project has wrapped up. It was 3 years. I think it was a really good project, a lot of data. We do have a new project funded by NCSRP. It's called Boots on the Ground. So it's taking this paper survey data that we generated and trying to look how it works in the field. So instead of doing paper survey, doing on-farm research. And it's to look at these factors here a little bit more in depth. So the goal for all of the states involved is to get 20 on-farm trials established. So far I have 15, and I think I have the most out of all the states so far, so I always like to make Ohio look good. So Ohio, we're doing pretty good. I'm still looking for five people willing to help us with this on-farm trial though. The caveat is we're focusing on very specific areas in Ohio. So this blue area here, that's that region 2 that we're focusing on. We're not focusing on region 1, which is northern Ohio, because that region is similar to Michigan and Wisconsin. So the guys up there will be putting on farm trials out, and that represent that region. So my responsibility is for this blue area in Ohio. So if you're around in one of those blue areas and you're interested, I would love to talk to you. The field requirements are a little bit loose. They're getting looser as we look for people. But we want fields that are tile drained because we did see a yield advantage to fields that had tile drainage. Reduced till or no till because that's representative of the state. And then also corn as the previous crop. There's 2 treatments. The first treatment is the improved system. So these were things that showed they were important in that paper survey. So in the improved system, we're asking farmers to plant the end of April or early May. So the early planting date at a slightly lower seeding rate, 130,000 seeds per acre, and then spray a foliar fungicide and insecticide tank mix at R3. And then we want to compare that to the second treatment, the standard system. The standard system is planting 3 weeks later than that first system at a higher seeding rate, 160,000 seeds per acre, and then no foliar application. So this is a pretty involved on-farm project, but these are the things that were important in that survey. So we're asking for at least 3 replications in the field, and it would be every other 1 strips in the field. The width of these strips is going to depend on the equipment size because we'll want 1 clean combine pass through the fungicide and insecticide treatment. So I'll take information like the planter width, the combine width, sprayer width, sprayer track tire width, things like that, and I'll help lay out that field. The width will depend on your equipment. And then the length of the strips, we're asking for at least 300 feet. If it's easy to go through your whole field to do the strips, longer is fine, that's not a problem. But OSU will help provide the trial layout. Any measurements that need to be taken in season, we'll do that. So we're really good at doing free measurements. So if you think you have an SEN field at the same time, we'll pull SEN samples. We'll do that. So we'll assist as much as possible with planting, spraying, harvesting. We'll help flag out where you need to drive the sprayer, things like that. And then we always keep our data really anonymous, or it's not anonymous, it's confidential. So in any report, the most you would ever be would be a red dot on a map. And then we would need, of course, the yield files, and that data will go to Wisconsin to Sean Connolly's group. So any questions about the trial? Everyone loves to do planting date trials, right? Every time I do a planting date trial, it ends up being a really horrible planting season. So this makes me a little nervous, but we'll see. I think it'll be a really good project. It'll be really good data, and Sean Connolly's group does a really great job analyzing this type of stuff. So I'm going to move on to talk about some of our soybean seeding rate research. We've been doing some of this small plots and then also on farm. In 2017 and 2018, we've had probably 8 on-farm variable rate seeding trials in Ohio. I'm going to focus on 2017 because we've worked through that data a little bit more than our 2018 data. So in 2017, we had 4 on-farm trials in these circled areas across the state. I'm going to focus on 2 locations, the one in north central Ohio and then the one in central Ohio, because I think those are both really interesting locations. So what we do with our variable rate trials, we let each farmer choose their prescription and rates. So the grayscale here on the map is the farmer's prescription, and the different shades of gray represent his rates. And then once we get his map, we put in replicated seeding rate strips. So these blue strips are a uniform seeding rate. We have low, medium, and high rates. Low is 100,000, medium is 140, and then high is 180,000 seeds per acre. And then North Central, I think this was a really interesting site in 2017. It was our site that was planted last, 2017. Does anyone remember 2017, or is that something you blocked from your mind? This was the year everyone enjoyed planting 2, 3, 4, 5 times in the same field. So this site for us was the latest that was planted. It was planted June 3rd because it was wet. It was the only trial in 30-inch rows. Everything else was 15. And this farmer, this is his field, he made his map and prescription based on previous year's yield. So he had 5 zones in his field. The lowest rate he planted was 80,000 seeds per acre. And there was really only 2 reasons he did this. 1, it was an extremely small portion of his field, and 2, it was not visible from the road. Only 2 reasons. But most farmers are not comfortable going that low, so that was really cool to see that. His high rate was 160,000 seeds per acre. So this is what I wanted to see as an agronomist. This was, I guess, maybe my wishful thinking. So usually when we do seeding rate trials or any rate trial, we look at yield versus seeding rate. And then since he based his zones on previous year's yield, I would hope that his zones would have different yield potentials, and there'd be some sort of curve. And once they have a curve, we can calculate where yield is the highest, and that would tell us what the optimum seeding rate was. So this is what I had hoped to see. This is what I saw. We didn't calculate the response curve for zone E because it was really small, but his zones all yielded about the same, and there's not much of a response curve. It's it's very much a flat line. But we did try to calculate the agronomic optimum rate. So here looking at zone A, B, C, and D, the agronomic optimum rate, which was what I calculated after the fact, and then compared to the farmer's prescription. Zone A here, I'm not supposed to call it a diamond. My daughter's in kindergarten, and the proper name of that shape is a rhombus. But my daughter can never remember what a rhombus is, but I tell her it's okay because farmers don't know what a rhombus is either. So raise your hand if you know what a rhombus is. 1. So I'll tell my daughter it's safe. She can still call it a diamond. But the blue diamond, that was zone A. There's no response curve at all. It's a flat line. So we think maybe that farmer could have gone with a lower seeding rate. We didn't test lower than 100,000 seeds per acre. But since there's a flat line, he probably could have seeded a little bit lower. His prescription called for 100,000 seeds per acre. Zone B, those are the orange squares. There is a slight response curve there. So I could calculate the agronomic optimum rate at 166,000 seeds per acre. His VRS prescription called for 120. And then zone C and zone D, there's a slight increase in yield with increasing seeding rate. So maybe he should have planted a little bit heavier than 180, but still not a great response there. So I think there's several take-home messages from this site. I think the first one is his zones correct? Sometimes it's really hard to generate yield maps based on yield history alone. It can take a really long time to see a pattern in a field. Looking at his 4 zones here, his lowest yielding zone was 34 bushels per acre. His highest was 37. So his zones did not yield differently. And other studies, this is from Wisconsin, they can see as much as 20 years of yield maps before a yield pattern can emerge, because weather is extremely variable, and then also crop rotation. The more crops you have in rotation, the longer it will take to see a yield pattern in a given crop. So I don't think the zones worked in this particular year. And it was overall an extremely low yielding field. Looking at all the yield data points, his highest was 50 bushels per acre, but the field average was 36. 2017 was a rough year. It was a rough year in northern Ohio. Not a great field average, but I think the two things agronomically that stuck out about this field for me was it was the last planted and it was the only one in 30-inch rows. I think those two factors came into play. This is looking again at that same planting date graph that I showed before. This field would have been in box A, half bushel per acre per day reduction in yield, and he planted June 6th. So I think there was a yield hit there. And then the other factor was the 30-inch row width. This is some data that we summarized across the U.S., looking at the advantage of row width, narrow rows 15 versus wide 30-inch rows. And there is always a slight yield advantage to having those narrow rows, but the yield advantage is magnified as you plant later. So row width may not matter as much in April. In June, it matters more. So I think those two factors came into play with this particular field. Any questions about that one before I move on? All right. So the other site I thought was really interesting, we call our Central Ohio 1 field. This field was the complete opposite. They planted on April 27th. So this was probably looking at Carrie's data, looking at our data, maybe more that target window of planting. But what happened in Central Ohio in 2017 if you planted early? Is anyone from Central Ohio?
You replant.
Yeah, unless you work with me and I don't let you replant because it would ruin my study. Yeah, they got extremely heavy rains, so just pounding rains right after planting. His field average seeding rate was 142,000 seeds per acre, which I think is a really solid, that's a good field average. We went 3 weeks later to do a sit-in count. The field average was 76,000 seeds per acre, or plants per acre. So he was about 50% loss. I know Carrie talked about loss from planting early, and I think she said like 20, 25. That's probably more normal. You get heavy rain. This was 50, and that was a field average, so we had areas that were lower than that. Final stand was even a little bit lower than that at 73,000 seeds per acre. So he had 4 zones in his field. His zones were based on a compilation of different factors. Zone A was the lowest seeding rate, 135,000 seeds per acre. Highest was 160,000 seeds per acre. These are his response curves. Zone A wasn't large enough for us to get a curve, so you're just looking at B, C, and D. Zone B and Zone C, there was a linear increase, so he had increasing yield when he had increasing seeding rates. He also had half of his plants left, so that's probably why. Zone D, there was a little bit of a response curve. We calculated the agronomic optimum rate at 172,000 seeds per acre. His prescription called for 160, so that was pretty close there. But what's really interesting about this site that blew me away was it was our highest yielding out of the 4 that year. That the field average was 62 bushels per acre. Is anyone surprised by that? If you would have saw how trashy it looked, you wouldn't be surprised by that, because it looked really bad in the spring. But 62 bushels per acre with a final plant stand of 73,000 plants per acre, which I think is outlines again how much planting date matters. I think if he planted in June and had that pounding rain and that final stand, I think his yield would have been really low. Given the fact he planted in April, I think it gave time for those plants to increase branches, the number of branches, and that really helps compensate for that lower population. So we did a lot of plant architect measurements for this study. So looking at 100,000 seeds per acre, the plants are thicker, they have thicker stems, and they're shorter, and you can see the number of branches they have. As we increase our seeding rates, those plants get taller and have no branches. And so in his field, at those low stands, he had these little plants with really just loaded branches with pods. So I think that was really cool to see. The other thing that was really interesting from this site was looking at yield losses. And I try to help my graduate students as much as I can in the field. There was three of us that day. One was in the combine with the farmer. One was on the four-wheeler collecting plant samples. And they gave me the job of collecting the beans on the ground. Because I don't know if they don't like me or they don't trust me, but that was my job. So we wanted to look at how plant architecture influenced harvest losses. And this site had the most harvest loss. So 4 soybean seeds on the ground, this is a 1 square foot area, is about 1 bushel per acre. And he had a lot of losses. We think the majority of these losses were because the soybean plants were so short. When you have short soybean plants, the lowest pod is closer to the ground, and they just weren't picked up by the combine. It was also a little bit drier too. I think he was harvesting at 8 to 9% moisture, which can contribute to loss as well. But here we're looking at total harvest loss versus final plant stand. Red is this side I'm talking about now. He had losses getting close to 5 bushels per acre, which is pretty significant. But the majority of the losses were at those lower final plant stands. So as stand increased, the losses were reduced. Just for comparison, in Central Ohio too, that's the green triangles, they planted mid-May, so they missed that first rainfall. And you can see a similar trend where there's more losses at the lower stands, but they were still under 1 bushel per acre. So at those extremely low stands, you will see more yield loss. So any questions about that before I keep moving along? Yeah.
How did you calculate your optimum seeding rate?
So the optimum seeding rate, what we do is I draw a curve, so I plot the data like this. And so zone B and zone C, I try to fit a curve or a line to that data. So in zone B and zone D, there was a linear trend. So there's a linear trend. We're assuming the optimum seeding rate was higher than what we tested, which is over 180. For zone D, that's the triangles here. You can see there's a little bit, I don't have the lines on it, but there's a response curve. So yield is lower, and then it increases and kind of tapers off. And I calculate the point where the seeding rate at the point where yield is the highest. Does that make sense? So that's what we do. And so we did this with all of our sites. Any other questions? So the big, I guess, 2 overarching themes for this project. First, how do we make prescriptions in zones? There's a lot of different ways people do it. What's the best way? And then the second question is, once we have our zones figured out, what's the optimum seeding rate to use in those zones? And these are really complex questions and very challenging to answer. I had a graduate student who looked at ways to make prescriptions. We did grid soil sampling on all of our fields at a half-acre grid scale. We measured all the soil properties. She looked at terrain derivatives as well. The one that's easiest to remember is elevation. If she was here, she would tell you about all kinds of curvatures and concave and convex, and you would glaze over, but she would keep going. But we won't go there. And then also soil map units. We couldn't look at previous year's yield maps because we didn't have that data for all of the farms. But lower error rates, that means that the zone was homogeneous or uniform. So that's what you want. You want your zones the same so they could be managed in a similar manner. So the lower error rates were associated with those high density grid soil samples. The 2 that kind of rose to the surface in terms of soil properties were potassium and pH. And then a lot of the terrain derivatives were important. For example, elevation was one of those. High error rates, so not the best way to make zones, were associated with soil map unit. The resolution wasn't great to do that, so that wasn't wasn't a great way for the sites we looked at. But what's really important to keep in mind is all of these important variables to make zones varied field to field. So there's not one field where one property worked and they worked for all of the other fields as well. There's a lot of variability there. What's interesting too about potassium and pH, when we can make zones based on potassium and pH, it's in fields that had extremely high and low K or pH, so there was a range there. And so our thought there, if you have low K or a low pH field, it's probably better to correct your problem than cover it up with seeding rate. For example, this is a field, this is Central Ohio, looking at pH. The light dots represent a pH of about 5, and then the darker dots up to a pH of 7. So with pH, that's a difference in acidity of 100 times. That's a big difference. And so you can make a variable rate prescription based on soil pH, but it's probably better just to apply lime where you need it. Finding the optimum seeding rate within each location is extremely challenging from on-farm research. We need a low rate that reduces yield. Some farmers are beginning to go lower than 100,000 seeds per acre, but you have to go really low, like the response curve. To get a good response curve, we have to have a really low rate and a really high rate. This is more typical what our response curves look like. This is for small plot data. So in small plot data, when I do seeding rate trials, I go down to 50,000 seeds per acre, and then I go up to 250,000 seeds per acre. When I get that range in seeding rates, I get a much better curve. And once I have that curve, I can calculate where yield is highest. Here is 211,000 seeds per acre. That's really high. There's two ways to look at this: agronomic optimum, highest yield. What's better to do is calculate the partial return and look at the seeding rate where return is the greatest. And here, that was probably closer to 150, 140, but we look at it both ways. But just that's the kind of curve we need to make or rates we need to make a response curve. I took this same data and deleted that 50,000 point just to see what my curve looks like, and it's kind of flat, maybe increasing a little bit. It's definitely non-significant. So that's the, I guess, take-home message of seeding rate work. If you really want a good response curve, you have to go really low. It's the same with Harold's nitrogen rate trials. You like a 0, but when you have a 0, you have a reduction in yield, and that's just the way it is. But that's one of the challenge for some of this on-farm research. I think one of the take-home messages for all of the seeding rate work we've done is that looks can be extremely deceiving. This is what we saw in Central Ohio 1 with the 2 inches of rain right after planting, a really thin stand. It looked really bad. And we were glad the farmer kept the field for us. So this is some of our small plot data. This is in Clark County, Western Ohio. 50,000 seeds per acre are our treatments. I'm not recommending you guys do 50,000 because you will have a yield reduction, but I think it's interesting to look at. We're looking at 30, 15, and 7.5 inch rows. The first set of pictures is from June 24th. The second is end of July, so 1 month later. And then these are the exact yields from those individual plots. So when we have 30-inch rows and 50,000 seeds per acre, I think in June that looks like the best stand. Would you agree? I think it looks the best in June. Going into July, you can see there's still bare soil in between the rows, so we didn't have complete canopy closure, and that's a problem that reduces yield. The yield of that plot was 61 bushels per acre. This middle one here, 15-inch rows, the sand doesn't look too bad. It's a little spotty. That plot yielded 78 bushels per acre. And that's Western Ohio, and we get really good yields here in that part of the state. If Mark Laux would was here, he'd ask about weed control. Yes, we did a really good job controlling weeds because JD worked for me, and JD really likes to kill weeds. So we did a good job with weed control, so that wasn't a limitation. 7.5-inch rows, the yield of that plot was 62 bushels per acre, so it was similar to the wide rows. When you drill soybeans at such a low rate, you don't get a uniform stand at all. It's very gappy, and then clusters. And so I think that was the problem with that field, or that plot. But soybeans really have an amazing ability to compensate for low stands. I would never intentionally plant 50,000 seeds per acre, but I think Carrie said her replant decision started at 50,000, and I think that's probably a good recommendation, because even at these low populations, if you plant early enough, the plants can compensate by putting on more branches. The other take-home message, and Carrie talked about this as well, was target final stand. It's really hard to figure out what seeding rate you need because you don't know what the year's going to bring and what problems you're going to have. But when we plant in May, I'd like to see 100,000 to 120,000 plants per acre at harvest. I think Carrie said 100. I put a little wiggle room in there. 100 to 120 at harvest. This is our data from the variable rate trials. I can make a little curve there, and the optimum final stand was 114,000 plants per acre across all of our sites. And this holds true for small plot research as well. We see this trend. That's a good rule of thumb. If you're planting in June, you're going to have a higher target final stand. If you have double crop soybeans, it'll be even higher. Our double crop soybeans, I usually plant at 200 to 250,000 seeds per acre. So there is a planting date seeding rate effect there. So I guess that's all I had. Do you have any questions? Yeah. Organic matter and CEC, so she's defending on Friday. So she had a graph or a table where she looked at all the important factors. Organic matter showed up important in one of the fields. I don't think CEC ever showed up as important, but CEC can be related to organic matter and other factors as well. So she listed the top 5 variables for all of the fields. Organic matter showed up once. The factors that showed up most were the terrain derivatives, so elevation, curvature, aspect, slope, which then can relate back to organic matter as well. But more than the soil factors, the terrain factors showed up as important, which I think is a really key point because your soil fertility factors can change in the field, but your slope and your elevation, those factors shouldn't change. So I think that shows a lot of potential for making prescriptions or maps based on those factors.
How early is crazy early for early?
How early is crazy early? So I think end of April is fine in most situations. If Ann Dorrance was here, she would make me tell you wait till 50 degrees. Wait till the soil is 50 degrees Fahrenheit. I think end of April is okay in some years, maybe some years not. But I like to see soybeans planted at least by mid-May. That would be my preference for the state. I don't know if Harold,
It'd be nice to be done by May 10th.
It would be nice to be done by May 10th. I'm comfortable with anywhere and it being done by May 15th. That would be kind of my unofficial cutoff. You don't want to push it too early. If it's good in April and the conditions are good, that's fine. If it's not, don't do it. With our trials, we're really sensitive to the weather. We do variety testing. We don't start planting till about May 10th because if we get hit with any problems, any late freezes, anything like that, we're done. So that's what we feel comfortable with. I think end of April to early May is good. Any other questions or comments? So if anyone is interested in that study I talked about earlier, the boots on the ground, and you happen to be in that target area, it'd be great to hear from you. I'm only 5 short. I'm beating Sean Conley in the number of people, so I'd like to really keep beating Sean Conley. So let me know. But thank you for your time.